Hey everyone, this is Miss Patel here. Welcome back from spring break. So we're moving on to the next unit we're covering, which is going to be on input, output tables, two variable equations. So the first section is input, output tables. So here are let's go over some definitions, vocabulary. Remember, I always talk about how vocabulary is important. A few of these you might actually know more from science class, since you work on this stuff in science class. So independent variable is a variable representing the input values. Dependent variable is a variable in a relationship that depends on the value of the independent variable. And we're going to see a few of those examples in the beginning of this lesson, what they mean, because identifying independent and dependent variables is really important in understanding real world situations. And again, you probably do this in science class, in labs. A relation is a pair of numbers according to a specific rule or equation. You're going to see a bunch of relations today in the tables. And an input-output table is a table used to describe a function by listing. Okay, here is a spelling error by me. Where's my pen? Okay, by listing input values with their output values. And again, function is not a Math 6 word. I probably will go into an extension lesson into pre-algebra / algebra on functions, but it is a big concept in Algebra 1 when you get to two variable equations, okay? So I kind of modified the explore activity that you would have done in class, and it's really about identifying independent or dependent variables. So let's go over this real world situation. Andrew reads 3 books each week during the summer. The equation y equals 3x represents the total number of books Andrew has read, y, based on how many weeks have passed, x. So y is the total number of books she's read, and how many weeks have passed is x. In this situation, the number of weeks that have passed is the independent variable. The number of books she has read is the dependent variable because it depends on the number of weeks that have passed. So think of any situation for the month of April. If you're reading, like, if you know that you approximately read 2 or 3 books a week, the total number of books that you've read is depending on the number of weeks that have passed. That's why the books read is a dependent variable, because it's dependent on the weeks that have passed. So part 1, in each relationship, underline the description of the quantity that is independent of the other quantity. So I'm going to do 2 things. I'm going to underline the independent, and I'm going to circle the dependent. So maybe if you want to try this on your own, pause the video right now and try to see if you can figure out what the independent variable, the quantity is, and what the dependent quantity or variable is. All right, so for A, the number of calories consumed and the number of apples eaten. So which is the independent variable, the number of calories consumed or the number of apples eaten? And the number of apples eaten is your independent variable, and your number of calories consumed is your dependent variable, because you can't consume any calories unless you eat apples in this situation. If you're not eating any apples, then you're not consuming any calories. Yeah, granted, in the real world, you're eating other things, but in this situation, you're looking at the relationship between these 2 quantities. B, the temperature outside and the number of people at the pool. So which is the independent one? And sometimes it's easier to identify the dependent variable, okay? So the number of people at the pool is going to be your dependent variable, because if it's a cold day outside, are you going to see a lot of people at the pool? No, it's going to see a lot less people. So the temperature outside is going to be your independent variable. C, the number of homework assignments completed and a grade in the class. And again, in real world situations, There's not a 100% correlation on this, but a general correlation does exist between these two quantities, the number of homework assignments completed and the grade in the class. Well, I would generally assume for a large percent of the population that the grade in the class is going to be dependent on the number of homework assignments completed. And generally, of course you're going to see some people out there that still do well in the class if they don't do a lot of the homework assignments, but you're looking at a specific type of student. And D, the amount of money spent at SNOCAP and the number of snow cones purchased. So the number of snow cones purchased is your independent variable because that results in the amount of money that you spent. Okay, dependent variable. So that's a way to identify independent and dependent variable. And then again, it's really important. We're going to be graphing points today. And when you're graphing points and you're only looking at the positive part of the graph, because we're not looking at random negative things in real world situations. Unless you're dealing with money or certain things, a lot of the times when you're graphing, it's going to be the first quadrant. So when you're graphing, the independent variable is your x, and the dependent variable goes on the y-axis, and the independent goes on the x-axis. So that's really, it is extremely important. If they've not been spelled out for you, which one's the x and which one's the y, it directly goes into graphing. And graphical representation is an extremely important thing in understanding numbers and data and everything. Anyway, part 2 of your Explorer activity. So Gregory sells corn dogs at the fair. He determines how much money he has collected based on the number of corn dogs he has sold. That makes sense. He uses the equation y equals 250x, where x is the number of corn dogs sold and y is the amount of money collected. Complete a table for the input values of 0 through 4. And we've done tables before. Now what's happening is that the input is going to be your x and the output is going to be your y. So this is why it becomes two variables. So our equation is y is equal to 2.050x. So that's what you're going to do. Your x is 0, so it's going to be 2.50 times 0, which gives you 0. So y is 0. And the same thing now, you have 1. 2.50 times 1 is equal to 2.50, so y is 2.50. 2.5 times 2 is equal to 5, so y is 5. 2.5 times 3 is equal to 7.5 or 750, and y is 7.50. And lastly, 2.5 times 4 is equal to 10, and y is equal to 10. Right? It's a way to complete a table. And the last part of this Explorer activity is explain why it makes sense that the number of corn dogs in the above relationship is the independent variable and not the amount of money collected. And I want you to think of this on your own. You have your own explanation for this, and I've talked about independent and dependent variables. So how about you try to really think through this and understand the difference? This is the conclusion of part 1 of this video. The rest of the notes are going to be in part 2.